you can share my screen, please.
Yes, we can see it very clear.
Okay, perfect. So thank you very much. So first of all, thank you very much for the given opportunity to be with all of you and present the capabilities and power of digitalization, the simulation, the digital twin onto the industry of any kind, from civil engineering to manufacturing, going through aviation, food and defense. So for me, it's a real pleasure to be here with all of you. So we are going to follow this index, starting with a general vision and fields of use of digitalization applied to industry, the performance of simulations and its core tools, the link to the digital twins, its benefits, and finally, some new technologies derived from them. So let's start. Our first thoughts regarding digitalization goes to industry and manufacturing in particular. It's a really good starting point, but not the only one, as we'll see in a few minutes. So think about the smart city, for example. Regarding product engineering, we can use the virtual world too. First, the conceptual design and specification. We can come up with our first ideas in a computer and see from the start the forcing performance of the item, component, or assembly we're designing. Even we can know if we meet the specifications according to the customer requirements and specifically legislation, everything from your PC or laptop. Secondly, the system engineering and structural design. So it's possible to complement our design with all the ancillaries attached to the system, from the hardware application standpoints and the simulation and the coordination between own components and subsystems. So it's like a virtual testing, and here is when the concept of digital twin enters in, a complete simulator where all the environments can be applied and be duly simulated in an unrisky and cost-effective way. So it's, so to speak, a full-scale replica, taking and giving information from all the elements acting in the scene and connected via IoT sets. So now 5G communications are going to be instrumental, and according to some sources, 6G, not 5G, but 6G is about to be born very, very soon. Mechanicals, electricals in smart cities, vehicles and factories, a complete city, a complete manufacturing plants can be replicated virtually with all participating elements. The engineering of full vehicles, data transmission, and the general condition of any machine and process we can come up. The design, verification, validation, and final deployments, virtually speaking, we can test everything to its limits and see the maximum capacities of systems, vehicles, factories, and even cities. So in one word, the simulation of all processes via the digital twins as virtual replicas, the virtual reproduction of a complete system. Now, thinking about the manufacturing engineering, the virtual approach can be applied to, first, the process engineering, the manufacturing lines, and the tooling simulation. So all kind of processes, lines, tools, and stations can be simulated to the slightest detail. It's very important to remark the simulators and the digital twins can get information not only from the real world, but also they are able to generate its own virtual data replicating the reality. So that's really important as to train artificial intelligence, the code of a digital twin. The algorithms especially designed to learn by themselves and able to adapt and change their logic according to the input they receive. Of course, the supply chain management, quality inspections are included in the concept of the digital industry 4.0 and 5.0. So think about, for example, computer vision and its capacity to identify objects and especially false effects of any kind, especially important in key areas such as aviation and electronics. So a digital twin is able to foresee predicted circumstances and risky environments much before they happen. So it's important to remark here the approach to predictive maintenance for vehicles and assets. So how it is to know not only the operational condition of assets of any kinds online and in situ, but to know in advance its evolution and when a likely breakdown can occur. So all measures to avoid these fall downs can be applied in an early stage, saving a lot of money and time and improving the user experience and customer satisfaction. And now, I would like to mention the importance of digitalization in such a specific area like a smart city. With a digital twin and proper simulations, we can test and train the traffic control, avoiding pointless traffic jams and hotspots. We can model the best routes and paths for transit and evacuation in case of emergency for all road users. We can take advantage of our sensors even embedded in all vehicles, you know, radars, lidars, cameras, and the like, to road inspection and see the status of signs, horizontal markings, and even the quality and the degradation of the pavements. Here, a digital twin can not only detect, but prevent, for example, the evolution of cracks, bumps, ditches on the asphalt in order to prevent accidents, for instance. So IoT communication from vehicle to vehicle, B2B, and to everything, V2X, will be instrumental to share not millions, but billions of bytes of information in the cloud and be knowledgeable about what's happening ahead of us. Our vehicle can transmit and receive information in the same way to be updated about any danger or simply the best routes from going to from a point A to a point B. And using the virtual worlds, even we can perform the self-calibration of the ADAS sensors thanks to IoT and into from other vehicles. Now, it is not needed to stop a vehicle fleet for some hours in the workshop to recalibrate the sensors with specific tools. Now we can communicate with other vehicles and the infrastructure, you know, traffic lights and the like, to get information and compare it with the information we are getting by ourselves. So if there is a match, our ADAS calibration is okay. If not, we can take the surrounding assets information as a pattern and recalibrate our sensors online and in a matter of a minute. And also remote driving of vehicles in urban areas and even open roads now is a reality made possible by IoT connection and the power of simulators and the digital twins replicating the environment, sporting a very extra low latency. So finally, getting real-time digital maps directly from data taken from vehicles and UAVs, drones, are possible to better plan the smart cities and factories of the future. I insist. So gathering information from the real world and combining it to virtual data generated by our DTs, all in all, they contribute to better training of virtual models. Now, we are discussing about the capabilities of real-time simulators for everything. So we can get the results of any simulation in real time, and it's possible to change the inputs online as many times as will. Our architecture system is model-based that enables to take and transmit information at once and very quickly. So that's its idea for instructional purposes, thanks to the RTE module, able to join different simulators at the same time, even if they are running from different computers and different protocols. So this paves the way to linking to any existing commercial software if needed. Our approach, obviously, at CT is apt for civil and military applications, you know, land vehicles, ships, and aircraft simulators, including UAVs, also known as drones. The digital twins are also compatible to replicate test benches and real equipment to go along real tests. Over this fact, results obtained from the digital twin are accurate and reflects the reality very faithfully. So furthermore, what's really interesting about the digital twins and its capability to generate virtual data is the power to update themselves, to update its features to the minute and the slightest detail, and to be the perfect replication of reality. So independently, if we talk about a factory, a smart city, a machine, or a vehicle. So This combination of real and virtual data empowers the capability of a digital twin, being able to simulate the more complex system and assemblies we can imagine. As we can see on the upper part of this page, also important is the connection to HMI, they mean to visualize all data in a user-friendly way through PCs, laptops, or handies to get all the information at once. So, alerts and advices to improve all kind of processes. So now, very important, all matters regarding machine, deep learning, and big data. So 3 concepts linked to acquire all relevant data from different assets, telemetry, IoT devices. With all these tools, we are able to predict, going far beyond the prevention, any failure in the near future. We are able to arrange and manage spares, logistics, maintenance works in advance to prevent the stopover of a manufacturing line, a fleet of vehicles, or any critical system. As mentioned before, the generation of virtual synthetic data to train advanced and complex AI algorithms and models is key to get the success. Also, we can get accurate replicas of testing grounds. This is especially important in case of land and aerial platforms to test any kind of subsystems in harsh environments. Here in this page, we can see as a matter of example, an electric urban bus. We think about replicating the life of key components, electric motors, battery packs, brakes, tires, and ADAS systems to know in advance and according to operating conditions and external factors, the temperature, vibrations, electromagnetic fields, productivity, and energy use, in one word, the foreseeable life of these components is what many companies are looking for. So, and last but not least, seeing all this data via graphicals contributes to enrich the user experience. Now, virtual, augmented, and mixed reality increase the performance of predictive models and personal training. So one image is better than 1,000 words, as we all know. Imagine we can achieve all docs and tech manuals at the fingertips and completely updated. It's really fantastic. So what's more, to get the help of another technician in the distance when we operate in harsh environments or simply in front of assets or a machine we are not familiar with. I would like to mention also our concept of operative simulation, LVC, live, virtual, and constructive. Earlier simulation is only useful from my standpoint if it meets these 3 virtues and features. So please be in mind that a real world is made up of dozens of systems operating at the same time. So if we wanted to replicate this set of systems, we have to be able to run all at the same time, also from different digital twins and from different platforms, as being a one and only set. So as we've mentioned, the digital twin is able to analyze a series of data in real time and represent them in a virtual environment using 3D engines. So we can see over this page an example of a facility used to train the transit in a road traffic. The compatibility of models is also instrumental. At City Engineering Group, our approach comprises the software in the loop, the hardware in the loop, and also, and most importantly, the human in the loop execution. In one word, all these 3 elements, side by side, and working as a whole and a unique entity. So no matter if we are modeling a city, a hospital, a vehicle, a factory, or an aircraft. So, I would like also to remark 2 of the main utilities of the simulation, the digital twins. We talk about image analysis by computer vision, and overall, the help us to make proper decisions. So arguably, this very last topic is by far the most important one, the ability of the virtual simulator of advising us on making decisions together when strong investments and even the life or people are at risk. And what can be said about the benefits? So the quality, safety, the speed, reliability, are among the most important benefits of SIMS and DTs. So we can increase the quality in the product and process design, as it's possible to correct initial errors from the outset. This is really important, as we can launch a product to the markets or commission a machine in a faster way. Human and machine can be produced in the loop to assess all the environments and all the areas. With this approach, we give the simulators all features to work in unison and not in an individual and less than useful way. So all assets are simulated and tested safer. We can detect from the outset any kinds of failures in the design and the day-to-day working operation. And in one word, the prediction of its long life. And the last message, especially for CEOs and the financial areas, thousands of simulations can be performed without the need of huge investments. So the advantage of simulators over the real estate based on errors and redesigns is more than evident. And finally, I would like to mention some key technologies growing very, very fast under the shade of the fourth and even the fifth industrial revolution we are living now. So I mean additive 3D and 4D printing. So please imagine the case that all kind of parts can be manufactured in situ from all kind of materials, even smart metals. Imagine you can design components able to transform its abilities and features depending on the environments and conditions, changing its shape, its conductivity. Imagine how the world materials and electronics can be changed drastically, coming up with the new devices, including breakthrough capabilities now out of our imagination. Imagine application, for example, in the health area, making prostheses perfectly adapt to the patients and their bodies and with no trace of rejection. So even a factory can self-suffice, making its own space, and no need to wait till any specific components. We can make it by ourselves, and that's important, with improved performance. So sounds good. And the other area I would like to mention is the one related to robotics and IoT, specifically the case of AGVs, AMR robots, vehicles and machines connected via IoT in harmony with humans. So that's the core of Industry 5.0. Now, with the digitalization, we can chase our goal dream of cities and factories perfectly automated and especially simulated via digital twins to ensure our growth as people and countries. Okay, so that's all from my side. So thank you so much for your kind attention.
Yeah.
And if you have any questions, I will be more than happy to discuss openly. Thank you very much.
Thank you very much. Because of the limited time, you just can take one question. It's what are the main benefits of merging competing companies in the context of digital transformation?
It's a question maybe for me.
Yes. What are the benefits of the new companies who are emerging, having technology and ideas? What is the benefit? Yeah.
The benefits of merging the technology of different company, is the symbiosis between both facts, not only the hardware and the software. And for me, and from my standpoint, is very, very important to join forces between different companies regarding the hard and soft, and specifically to create this virtual world to simulate everything, especially to save time, money, and to be much more safer. And well, that's the way and the path we're following on. So the industry, not 4, but 5.0, with the combination between the humans, the machine, robotics, and vehicles, factories, and smart cities. So that's, for me, the main advantage.
Okay, thank you very much. And now we move on. So thank you, Santiago, and simple appreciation to you. And we all learned from you. Thank you for the valuable session, and from all instructors.